Hello, and welcome to the first video of Scan DRC series. I'm Akanksha Pushkar from Technology Enablement Team at Siemens EDA. In this session, we will explore various scan design rule checks and understand their role in ensuring robust scan design implementation. Scan DRC is a crucial verification step performed after scan insertion to confirm that the scan architecture is logically correct before proceeding to pattern generation. It checks for rule violation that can affect testability, data shifting, or clock behavior. In scan mode, common checks include proper connectivity of scan chains, correct handling of clocks, set and reset signals, stable signal values during shift operation. By running Scan DRC, we can detect and fix potential scan issues early, ensuring reliable scan test generation and a smoother downstream DFT flow. So let's start with the first violation, which is T5 violation. What is T5 violation? The tool traces every scan chain in the design. It starts from scan out pin, which is assumed to be in an unknown state during shifting. Tool follows the X path backwards from scan output towards the scan input. If the trace path is broken anywhere, it means there is a problem in the scan path and a T rule violation is reported. A T5 violation happens during scan shift procedure when unknown state is placed on clock input or active values on set reset input of memory element. So in simple terms, we can explain here is during scan shifting, clock should never be uncertain and set reset pin should stay inactive. When does T5 occur? T5 occurs when the tool transitions from setup mode to analysis mode during scan DRC checks. If a broken chain is detected during this transition, the tool halts in the setup mode and reports a T5 error. Significance of T5 is scan chain integrity is broken. A section of the scan path is either disconnected, blocked, or incorrectly configured. T5 can occur in these contexts. And one important point here is T5 is always treated as an error. We cannot downgrade its severity to warning because a broken scan chain directly impacts testability. Possible causes of these errors are shift clock defined incorrectly in shift procedure, missing or incorrect pin constraints, missing clock definition, incorrect off state of clock can also cause T5 error. Next, here we are discussing about the T5 violation in detail. We will see how T5 violation is reported and how we can resolve this violation. So let's go step by step. After the initial setup of loading your design, first step would be reporting the violation. So running the design rule checks by command set system mode analysis or check design rules. After this step, the tool reports multiple T5 violation here, meaning some of the scan chains or memory elements are not meeting the required shift condition. Second step here is analyzing this violation. Now the visualizer window is automatically opened, filtering out the view to show only T5 specific violation. We are doing this through analyze DRC violation T5 command. So there are two methods here to analyze this. First is use of a report gate command for clock B to confirm details. The output appears in the command prompt, including that clock B is not defined at this step. Another method here is using the visualizer interface. We can easily pinpoint where the issue occurs in the scan path. Next, we'll examine this violation in detail by enabling the gate report settings and selecting the state stability option. This view provides the signal stability information related to T5 violation, showing load, unload, test setup, shift and capture values of clock beat during driving the D flip-flop. This view represents the same detail previously obtained using the report gate command in the command prompt. Now, to resolve this issue, we explicitly define clock B using add clocks command and specifying its offset value to accurately represent its timing. Next, we update the test procedure file and remove the previously created scan groups. After making these changes, we rerun the flow and validate by executing the set system mode analysis command again. The T5 violation now is cleared, confirming that the undefined clock B was the root cause of the problem. Here we can see the comparison between original test procedure file and the updated version after defining clock B. As highlighted, the definition of clock B and its associated pulses are now included in the time plate. These updates are reflected in test setup and in load unload procedures. This comparison shows the design state before and after T5 violation. The first view illustrates the violation when clock B was undefined, while the second view reflects the updated state after defining clock B and modifying the test procedure files. In the updated state, signal stability now displays the pulsing values of clock B, confirming that the violation has been resolved. This brings me to the end of the first video of the Scan DRC series. For any queries, please contact me at the email address provided. We will continue with more Scan DRCs in the upcoming videos. Thank you.